Okay, we are moving on to the next section. The next section is going to be over rationalizing lovely little radicals and things of that nature. You're not going to love it. It's not going to be something you're going to say, can we do that every day? But it is something you still have to learn. Yes? No. Good. Good talk. Great talk. Now, chapter 6, 1 and 2. When a negative is under an even root, this means the number is in the imaginary number system. Example. Square root of negative 16 is 4i. Remember, we talked about that before. We did that. Now, the index is the number inside the root. Part of the symbol, the radical, this is the check mark symbol, and the radicand is the number, the value under the radical symbol. So, if I give you the square root of 6, what is my index? Nope. The index is a 2. There is an imaginary 2 right there. See, it's there, but it's going to go away. And you have to know that it's going to go away, and it's not going to be there. So the index is going to be the square root of 2. See, it's gone. I told you it's gone. Okay? This is the square root. If there's nothing there, it automatically is understood to be a 2. Do we all understand that? Kind of like having an x, but it's a 1x. I'm magical. I'm magical. Yeah. Don't take that magic from me, people. Okay, now with that said, the cube root of 24x. What is the index of that one? It is going to be the cube root, which puts me right there. That is the index. Okay? That is your index, as well as the index is right there, which is 5. Do we all understand that? This index is understood to be right there, and we already know that that is understood to be a 2, and that's going to disappear, yes? Now the next one is going to be our lovely little radicand. What is my radicand going to be? That's going to be 24x. That's going to be 15x squared. That's going to be 6. Those are all examples of my radicand. Do we all understand that, yes or no? Okay, now, can I take the cube root of a positive 8? Meaning, what number multiplied by itself 3 times is positive 8? How do we know that? Well, 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. That is 2 cubed, which means my power and my root cancel out to give me just 2. Yes, I can take the cube root of a positive number. Can I take the cube root of a negative number, such as negative 8? What number multiplied by itself 3 times is negative 8? Negative 2, let's try it. Negative 2 times negative 2 times negative 2. A negative times a negative is a positive times a negative is a negative. So the outcome is going to be negative, and we already know that 3 twos is 8. So therefore, the cube root of negative 2 cubed, power and root cancel out, is negative 2. Is there a number multiplied by itself twice that will give me negative 16? 4. Nope. No. 4 times negative 4 is the only option that I can get to get a negative outcome. Do we all understand that, yes or no? Which means having $4 in your pocket and owing somebody $4 is not the same number, is it? So what this means is there's no real answer to this. Which is why we went ahead and rewrote this as negative 1 times 4, which is I squared times 4, which is going to be, oh, I hate it when I do that. I was putting the answer in there. Which is going to be 4i. Do we all understand that? Okay? Yes? Super important for your brain to grasp that information. Now, When we are dealing with numbers, we can easily say, if I say, hey, the number -3, is that positive or negative? And you're like, hey, that's negative. Okay, well, what about 7? Hey, that's positive. You can clearly tell if it's positive or negative. What if I say it's x? X is what we call a variable. Since it's a variable, I'm not indicating whether my variable is positive, and I'm not indicating if my variable is negative, because we don't know what x is. X could be positive or x could be negative based upon what the value x is given to be. Yes? Now, with that being said, the next statement is going to kind of screw with your head. When you are taking the even root of a variable, and the outcome has an odd power, you must use absolute value bars to ensure that the value remains positive. What do I mean? If I have the square root of x squared, the square root of x squared, I don't know what x is, do I? Is that a true statement? I have no idea what x is. I just know if I take the square root of x squared, the power and the root cancel out and it gives me x. The thing about it is that will only work if I know that x is always going to be positive. Well, the way I'm going to know that it's always going to be positive by simply putting the absolute value bars around it. Does that make sense? Okay? When do I need absolute value bars? I only need absolute value bars when I'm taking the even root. And the outcome of the variable is an odd power, and that's when I'm going to use absolute value bars. I only need the absolute value bars when I'm taking the even root, and the outcome of the variable is an odd power. Example. What is the square root of 64? This comes out as an 8. What is the square root of x to the 4th? Take your power of 4, divide it by your root of 2. What is 4 divided by 2? So my answer is going to be 8x squared. Now, x squared, what is the outcome if you take any number and square it? Will it be positive or will it be negative? No matter what? No matter what. So that means that I don't need absolute value bars here, because no matter what x is, whether it's a positive number or a negative number, if I square it, the outcome will remain positive every time. So I do not need absolute value bars here. More importantly, the reason why I don't need absolute value bars there is because my outcome of my power is an even power, not odd. So let's go here. What is the square root of 169? It is 13. And what is the square root of y to the 10th? Y to the 5th. So this is going to be 13 y to the 5th power. Now 13 is a number, and that 13 is positive, so it's going to be forever positive, correct? However, I have y, and I don't know what y is. But if I take y, that's a positive y, and I multiply it by itself 5 times, my outcome will be positive y to the 5th, right? What if y is negative? If I multiply negative by itself 5 times, what will the outcome be? Negative. Am I allowed to have my variable be negative ever? No. So that's why you're going to put absolute value bars around that to ensure that it remains positive. Now, why am I able to do that? Because I took an even root, because it's the square root, of the variable, and my outcome was an odd power because 5 is odd, and that means I need absolute value bars to keep it positive, no matter what. Do we all understand what I said? This is a hard concept, so we're going to do a couple more examples. Okay? Same concept, here we go. What is the square root of y to the 30th? Y to the 15th. Now here's my question. Did I take an even root? Yes, it's the square root. Is my power that came out of my even root, is that power odd or is that power even? It is odd, which means I have to put absolute value bars to ensure that it remains positive. Next, the cube root of x to the 6th. What does that come out as? X squared. Do I need absolute value bars? There are 2 reasons why you do not need absolute value bars. The first reason is what is the root of this function? Cubed. which means the cubed root is not an even root. It's not a square root, a fourth root, a sixth root, an eighth root. It is an odd root. So therefore, I don't ever have to worry about that. Why? Because I showed you in this example here that I can take the cube root of a positive number and I can take the cube root of a negative number and it be in the real number system. Yes? Which means it's legal. Which tells me that this right here does not need absolute value bars and it's completely done. The second reason I don't need absolute value bars is because it's x squared. And if you square any number, positive or negative, the outcome will always be what? Positive. Do we all understand that? Okay, next, rationalizing radical expressions. Now, do you remember whenever I taught you imaginary numbers and I said, we cannot divide by an imaginary number. You have to multiply by what you need to turn into an I squared or multiply by the conjugate. Remember us talking about that? Well, you can't divide by a radical either. Okay? So no radicals can be in the denominator, and rationalizing is the process used to eliminate radicals in the denominator. So how do we do this? I give you the square root of 1 over 13x. What I want you guys to do is to divorce the two fractions. Right now you have a numerator and a denominator. You tear it apart and write it as two separate problems. Meaning, this is going to be the square root of 1 over the square root of 13x. Do we see that? Yes or no? We good? Okay, what is the square root of 1? It is 1. And this is the square root of 13 times x. I cannot do anything with that, can I? Now, how many of any item must you have to pull one of those items on the outside of the square root symbol? 2. If it's the cube root, I'd have to have 3. If it was the fifth root, I'd have to have 5. If it was the 10th root, I'd have to have 10 to pull out 1. Okay? So I need to have 2 13s inside there and 2 x's inside there to pull 1 13 and 1 x on the outside. Do we all understand that? So what you're going to do is you're going to multiply by what you need. So I need another 13 and I need another x. Do we see that? What you do to the bottom, you must do to the top. So that gives you the square root of 13x over 13x times 13x is going to be 13x quantity squared, and I'm taking the square root of that. Yes? What happens to the power in the root? These cancel out, and I'm left with the square root of 13x all over 13x. Is it ugly? Yeah. Is it something you have to do still? Yeah. Okay, you see this? This is the chart that looks very similar to the last chart that you memorized, which is the perfect square chart. This is the perfect cube chart. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 7 cubed is 729. And 10 cubed is 1,000. Now, generally speaking, everybody memorizes up to 5. And they also know that 10 cubed is 1,000. And you guys do pretty well. Okay? Memorize those, you'll make your life a little bit easier. If you don't memorize them, you're going to have more punching on the calculator. Okay, here we go. I'm going to show you tonight's homework. And we're going to do a ton of examples together in class right off of your homework. Yeah? I think you guys like it whenever I do your homework before you guys get examples. Makes it a little bit easier for you. If you don't like it whenever I do your homework for you, you'd rather me just make more examples. Oh, geez. Okay. Problems 1 through 4. Are you ready? It says find each real root. It says real. Meaning if it doesn't have a real root, what do you write? No real solution. Do we all understand that? So if I look at number 1, This is a negative on the outside, which is the same thing as negative 1 times the square root of 25. What is the square root of 25? That comes out as a 5. So what is negative 1 times 5? Negative 5. Number 4, that is the cube root of 0.001. I do not want you to use a calculator. What I want you to do is use the place value. The tenths, the hundredths, the thousands. So this is 1 over 1,000. And you're going to take the cube root of the top and the cube root of the bottom. Do you see that? What is the cube root of 1? What is the cube root of 1,000? So 1/10, which is the same thing as 0.1. Better show me the work. Number 3, look at it. It's the square root of negative 0.01. What can you conclude? Square root of negative 0.01. Can I take the square root of a negative? So what do you write? No real solutions for number 3. Okay, next set of instructions. Simplify each radical expression. Use absolute value bars when needed. It wants absolute value bars for problems 5 through 13 if you need them. When do you need absolute value bars? They only go around variables that first were given the square root, the fourth root, and even root of, and then the powers, the outcome was an odd power. Do you all understand that? Even root, odd power, require absolute value bars. So here we go. What is the square root of 81? That comes out as a 9. What is the square root of x to the 4th? So I have 9x squared as my answer. I did take an even root, but do I have an odd power? I do not, so there's no absolute value bars needed. I am done. Number 6. What is the square root of 121? 11. What is the square root of y to the 10th? Y to the 5th. So I have 11 y to the 5th. Now, did I take an even root? Yes, I did. It's the square root. That's an even root. Do I have an odd power? Yes. So do I need absolute value bars? Yes. And you only put them around the variable, not around the number 11, because 11 is already positive and 11 is defined. I know that it is going to be a positive number. You only put it around the variable. Next, number 8. I'm taking the cube root of negative 0.008. What do I do? I'm going to look at the decimal, and this is the tenths, the hundredths, the thousandths. So that's negative 8 over 1,000. What did I need to do in there yet? Make the cube root of the top and make the cube root of the bottom. What is the cube root of negative 8? Negative 2. And what is the cube root of 1,000? And what is negative 2/10? Negative 1/5, and I am done. Does that make sense? Next, number 12. What root am I taking? The cube root. Can I have any absolute value bars on this problem? Even root, odd powers. This is an odd root, so I don't need to worry about it. So what number? I'm going to first go ahead and divorce these and put them into 2 separate problems. What number multiplied by itself 3 times is 64? It is 4. And what is the cube root of x to the 9th? What is the cube root of 343? I need to have any absolute value bars? I am taking the cube root, which is an odd root, so I do not need absolute value bars because it wasn't the square root or the fourth root or the sixth root. It wasn't an even root. The index is 3, which is odd. Okay, next. I signed it, you filled it. Just go for the collection. Okay, what do we do here? I'm taking the fourth root of m minus n to the fourth power. They do cancel out, and I'm going to be left with m minus n, but it's raised to the first power. Why did I put the first power there? Because I took an even root, and if I take an even root, I have the potential to have absolute value bars, because I have variables, yes? My power, after I took the even root of that variable, turned out to be an odd power, which means I have to have absolute value bars around it to ensure that the quantity m minus n is a positive quantity and not a negative quantity. Because if that quantity is negative, then that puts me in the imaginary number system, and I can't do that. Do we all understand that? Next set of instructions. This says simplify and assume all variables are positive. So how do I do the cube root of 45 times the cube root of 75? This is a review problem. We already did this. What I want you to do is check to make sure that the indexes of the two root problems are the same. Are the indexes the same? Marry them back together. So this is 45 times 75. And I want you to think of factors of 45 that are perfect squares or perfect cubes. And the answer to that is going to be 9 times 5. Why? Because 9 is not a perfect cube, but it is a perfect square. Perfect squares of 75 are going to be 25 times 3. Now, what's in the value 9? What makes up 9? 3 times 3, which is 3 squared. So how many total 3's would be underneath that radical then? I would have 3 3's. How many 5's do I have underneath that radical? One more time. How many 5's would I have? 3, because 25 is 5 squared, and there's another 5 there to make that 5 cubed. Yes? And what is the cube root of 3 cubed? That comes out as a 3. The cube root of 5 cubed comes out as a 5. And what is 3 times 5? 15. Yes? Let's keep going. Number 17. What do you notice about those two problems? One is negative and one is positive. However, my indexes are the same. So can I multiply them together since my indexes are the same? Yes, one is negative 16 times positive 4. Negative 64. Now, does anybody know what the cube root of negative 64 is? Number multiplied by itself 3 times is negative 64. Negative 4 is the correct answer. Keep on going. Number 20. Now let's read the instructions. The instructions say simplify. Assume that all variables are positive. Now here's my question. What does that mean again? Assume that all variables are positive? Assume that all variables are positive? If they're all positive, there's no imaginary, which means all the variables are always going to be positive. So do I need any absolute value bars? No absolute value bars are needed. So what do you notice about number 20? The indexes are the same, and they're currently divorced. They're written as two separate problems, numerator over denominator. Did I do that? Yes, so let's go ahead and do that. So this is 54 x to the 5th y cubed over 2x squared y. Now, can anybody tell me what 54 divided by 2 is? It is 27. How many x's are on the top? 5, and how many x's are on the bottom? 2. So how many x's would be left after canceling, and where would those x's be located? X cubed would be located in the top. How many y's are there in the top? How many y's are in the denominator? So how many would be left where? Y squared, and they would be left up top. Do we see we no longer have a denominator? Okay, we need to finish the problem. So I need to now reduce 27. What are the perfect square factors of 27? 9 times 3. How many x's are underneath that square root? 3. My power of 3 is not divisible by my index, which is the root of 2, is it? So I'm going to simply break it down and make this an x squared times an x. Because I still have 3 x's inside there, but one of them is divisible by my root now. Does that make sense? How many y's are inside there? 2. Is my power of my 2 on my y divisible by my root or index, which is 2? Yes, so I'm going to leave it alone. What is the square root of 9? 3. Can I take the square root of 3 on the inside? No. What is the square root of x squared? What is the square root of x? Can I do anything with that? What is the square root of y squared? So my answer is going to be 3xy times the square root of 3x, which is what remains. Now, here's the question I have for you. The direction set assumed that all variables are positive. However, had the directions not had that sentence, my question is would I need absolute value bars around my variables x and y? How can you determine if you need the absolute value bars around the x and y? Do I have an even root? Yes, I had an even root, which is the square root. And my powers on my variables, are they even or odd? They're odd, which means I need to ensure that they would be positive by putting their absolute value bars around. Do we all understand that? Yes or no? It's a hard one to do. This right here indicates that the root is even, and because this is x to the first and y to the first, they could have the potential to be odd. They are odd, I should say, but they have the potential to be negative. I don't want them to be negative, so I would put absolute value bars around to ensure that they are positive. So let's do another one. 23, what do I do? Marry them back together. So I'm going to marry the stuff on the outside. 2 times 7 gives me a 14. And then I'm going to marry the stuff on the inside. 3 times 6 is 18. I have an x cubed, and I have a y and a y squared to give me a y cubed. Does everybody see that? Yes or no? Okay, so now I'm going to break this down. I'm going to look for factors of 18 that are perfect squares. Do I have any factors of 18 that are perfect squares? 9 times 2. Is my power on my variable x divisible by my index? No, it is a power of 3. 3 is not divisible by 2. So I'm going to come down one step from 3 and make that 2 and a 1. Is my power of 3 on my y divisible by my root of 2? No, so what does that become? Y squared times y. Does everybody see that? So now what is the square root of 9? 3. Can I take the square root of 2? No, so it stays. What is the square root of x squared? What is the square root of x? Stays. What is the square root of y squared? And what is the square root of y? Stays. So now I want you to multiply the 14 times 3 times x times y. What does that give you? 42xy times the square root of 2x. Now here's the question. Yep, I totally lost out my line. Thanks, man. Now here's the question. Would this problem require absolute value bars around the x and the y attached by 42? Why would it require absolute value bars? Because it's an even root with odd powers after you take them out of the bars. After you take them out of the root. Okay, last type of problem we have to do here is rationalizing. How do I rationalize this? I have the square root of 9x over 2. I'm going to divorce these. Make this the square root of 9x over the square root of 2. What is the square root of 9? That comes out as a 3, so I'm going to have 3 square roots of x over the square root of 2. I can't have a lovely radical in the denominator. So I have to have a pair of 2's to pull out 1, 2. So I'm going to multiply by what I need, which is the square root of 2 over the square root of 2. And that's going to give me 3 square roots of 2x over the square root of 4. And what is the square root of 4? It is 2, so that's 3 square roots of 2x over 2. Tell me out of here. Okay, I will start off on Monday with 27. Yes? I want you guys to try. It is your homework. Okay? I want you guys to try them all. I will tell you right now, divorce these and multiply by what you need. Have a great day.